In 1945, an engineer named Percy Spencer was standing in a lab at Raytheon working on military defense. He wasn't trying to cook dinner, he was testing a piece of high-powered radar equipment called a Magnetron. But as he stood near the machine, he noticed something strange, a warm sensation in his pocket. Spencer reached in and pulled out a chocolate peanut bar he'd been saving for a snack, but it wasn't a bar anymore. It was a sticky, gooey mess. The radar equipment hadn't shocked him, but it had mysteriously cooked his lunch. Curious, Spencer sent a colleague to fetch a bag of popcorn kernels. He placed them in front of the tube and pop, 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 the world's first microwave popcorn was born. It was an accidental discovery that changed the way the world eats. But nearly 80 years later, most of us still don't know what is actually happening inside that metal box. Today, we are looking at the invisible science of the microwave, right here in Simple Things Surprising Histories. To understand how your cold leftovers turn into a hot meal, we have to start with the heart of the machine. It's a component called the magnetron. It sounds like a villain from a comic book, but it is actually a vacuum tube, essentially a high-powered whistle. But instead of blowing air to make sound, the magnetron uses electricity and powerful magnets to spin electrons around. As these electrons spiral, they generate electromagnetic waves, specifically microwaves. These waves are a form of energy, just like light or radio waves. In your kitchen, they vibrate at a very specific frequency, 2.45 gigahertz. Once the magnetron spits these waves out, they are guided into the main cooking chamber. The metal walls of the microwave act like mirrors. They reflect the waves, bouncing them around the box like an invisible high-speed game of billiards. So the box is filled with bouncing energy, but how does that energy actually generate heat? This is where the physics gets fascinating. The secret to microwave cooking isn't heat in the traditional sense, it's friction. Microwaves are specifically tuned to affect water molecules as well as fats and sugars. A water molecule is what scientists call a dipole. That means it has a positive end and a negative end, sort of like a tiny magnet. When those electromagnetic waves bounce through your food, they create a rapidly changing magnetic field. The positive end of the water molecule tries to align with the field, but the field flips back and forth billions of times per second. Imagine trying to turn around to face a friend, but that friend teleports behind you 2 billion times a second. You'd be spinning pretty fast. That is exactly what happens to the water inside your food. The molecules twist and turn frantically, trying to keep up with the waves. All that twisting causes them to rub and crash against their neighbors. Just like rubbing your hands together creates warmth, this molecular friction generates intense heat. This is why dry plates usually don't get hot, but the food sitting on them does. No water means no dance, and no dance means no heat. Now, if these waves are powerful enough to boil water in seconds, why are they safe to have on our kitchen counters? Why don't the waves cook us when we stare through the door? The answer lies in that perforated mesh screen you see in the glass window. This is called a Faraday cage. Think of the microwave waves like basketballs. The holes in the mesh screen are like a chain-link fence. The air and the visible light, which are tiny, can pass through the fence easily, allowing you to see your food. But the microwaves themselves have a physical wavelength of about 12 centimeters, roughly 4 to 5 inches. They are simply too big to fit through the tiny holes in the mesh screen. They hit the screen and bounce right back into the box to keep cooking your food. As long as that door is closed and the mesh is intact, the energy is trapped. So the next time you reheat your coffee, remember, you aren't just using heat, you're using a World War II radar component to force water molecules into a friction dance at billions of cycles per second, all safely contained behind a physics-proof shield. It's a marvel of engineering, sitting right next to your toaster. If you enjoyed this look at the hidden history of everyday objects, please hit the like button. It really helps the channel. And make sure to subscribe to Simple Things for more surprising stories. I'll see you in the next one.